These notes go over how to solve and graph inequalities, and it kind of has a lot to do with one-step equations. So to solve inequalities, think of them as one-step equations and use inverse operations to isolate the variable. So right here it says 2 times x is less than 18, and then I have the little key at the top, because if it doesn't have the line underneath of it, it's graphed with the open dot. And if it does have the line underneath of the inequality, which means it's either less than or equal to or greater than or equal to, then it's graphed with the closed dot, which you learned that the other day. So on this first one, all you got to do is take out the inequality sign and replace it with the equal sign. So now it's a one-step equation. So 2 times x equals 18. The opposite or inverse of multiplying, because that's multiplication, is to divide. So you would divide by 2 on both sides of the line that you've drawn, which means x equals, 18 divided by 2 is 9. And then you have to plug your inequality back in. So the inequality, again, it's right here. It's a less than sign. So x is less than 9. And now you have to graph it. Remember, they're graphed on number lines. And since it's just one of these inequalities, there's no line underneath of it. It's graphed with the open dot. And for some reason, it's always graphed above the graph and not directly on it. So you'll put a dot above 9, an open one. And then it's saying x is less than, so the arrow that you draw needs to be going through numbers that are less than 9, which would be this direction. So that's how you graph and solve an inequality. The next example is x plus 4 is greater than or equal to 10. Let me pick out a different color here. So I put an equal sign in already. The inverse of adding 4 is to subtract 4. So we've got x is equal to, 10 minus 4 is 6. So plug your inequality back in. It's right here. It doesn't change directions. You just literally put the same thing back in. So x is greater than or equal to 6. Since it's greater than or equal to, you have to graph it with a closed dot above 6. That's the best I can do. And then since x is greater than, your arrow needs to be going through numbers that are greater than 6. So it would be going this direction. Next one, I think I did an example of each type of operation. So now we're on subtracting. So x minus 1 is less than or equal to 6. Plug in the equal sign so we can solve the one-step equation. The inverse of subtracting 1 is to add 1. This is really sloppy, sorry. So x equals 6 plus 1 is 7. Plug your inequality back in. So x is less than or equal to 7. Now you need to have a closed dot above 7. And then it's saying x is less than. So you need to have your arrow going through numbers that are less than 7. So this way. And then on the last one, if you want to go ahead and try it on your own while I'm working, go for it. If you still don't understand it, then just watch as I work through it. So it says x divided by 3 is greater than 2. So I put the equal sign in, and the inverse of dividing by 3 is to multiply by 3, so that little dot means multiplication. So we've got x equals, 2 times 3 is 6. Plug your inequality symbol back in. So x is greater than 2. No, I don't know why I just said 2. 6. So put an open dot above 6. X is greater than, which means the arrow is going to be going this way because these are the numbers greater than 6. Another thing that I learned whenever I did this in middle school, the inequality it only works if the x is on the left side. See what I mean over here? The x is on the left, the number is on the right side, the x is on the left, the number is on the right side. If it's set up like that, then think of the inequality symbol as the tip of the arrow, so it's going that way. On this example, the inequality arrow, if you understand that, then roll with it. But if not, you can just do what we have been doing, where if it's less than, it needs to be going through numbers that are less than whatever. So make sure you have all that copied down and glue it into your notebook and go on to the next assignment.